Hi friends, welcome to Sunil Engineering Academy and I am Sunil. We have already completed Physics class 1 to 8. In this, we are going to discuss Physics class 9. The topic is units and dimensions. Okay. First of all, what is unit? We know that the unit is nothing but it is a quantity. It is a quantity used as the standard of measurement. Okay. For example, for the length, we measure the length in meters or kilometers or centimeters or millimeters. We measure the length in the following units. So these all are called units. Okay. For example, for time, we measure the time in microseconds, milliseconds, seconds or minutes or hours, days or weeks or years. All these are units of this time. Okay, but mainly we use the seconds is the unit for time. Okay, here in these units there are mainly four system of units. Coming to the system of units, there are mainly four systems of units. First one, FPS system, CGS system, MKS system, and fourth one is SI unit, system of international. Okay, and first of all, coming to the FPS system, in any system we represent mainly three fundamental quantities. The three fundamental quantities are length, mass and time. Okay, for in case of first one, FPS system, here as the name itself, FPS, F for foot, P for pound, S for second. So in this representation, in this FPS representation, that is length, mass and time. Here for length it is the foot, for mass it is the pound, for time it is second. Okay, in this way we represent the three fundamental quantities. They are nothing but length, mass and time. Okay, for this in FPS system, length is measured in foot, mass is in pounds, for time it is seconds, that is FPS. Okay, in case of CGS system, length, for mass it is grams, for time it is seconds. So the units of this length, mass, time are centimeter, gram and second respectively, that is CGS. Okay, for length it is centimeters, for mass it is grams, for units of time it is seconds. Okay, the next one system, that is MKS system. In this, the three fundamental quantities are measured in meter, kilogram and second. Meter, kilogram and second. For length it is the meter, for mass it is the kilogram, for time it is second. Okay, for length meter, mass kilogram, for time second, MKS. Okay, these are the three systems. And coming to the next one, international system of units, that is SI units. Okay, SI units. In this SI units there are 7 base units and 2 supplementary units. 7 base units and 2 supplementary units. That means here 7 base units are: first one length, second one mass, third one time, fourth one thermodynamic temperature, next luminous intensity, electric current and amount of substance. For these quantities, the units of this SI units, for length it is meter and it is denoted by the symbol M. For mass, the SI units of for mass is kilograms and symbol is kilogram, kg. And SI units of this time, seconds. SI units of this thermodynamic temperature is in Kelvin, denoted by K. luminous intensity. Units for this luminous intensity are candela, denoted by CD. For electric current, amperes, denoted by amps A. And amount of substance, that is mole, denoted by mol, mole. Okay, these are the 7 basic units. And the next one, 2 supplementary units. These supplementary units are, first one, plane angle. The name of the unit is radian. The symbol is rad. Second one, solid angle. Units for this SI units for this solid angle is steradian and symbol is SR. Okay, these are the SI units of 7 base units and 2 supplementary units. And the next one, derived units. Derived units are nothing but we can derive the units from these 7 base units. These are the units which are derived from these 7 basic units. Okay. Derived units, the units which are derived from those fundamental units. For example, if you take the velocity is nothing but, the units for this velocity is meter per second. That is, it is derived from basic unit, length and time. Okay, so that's why these units are derived units. For example, acceleration. The units for this acceleration is meter per second square. So here it is also derived from fundamental units, that is meter and second. Okay, these are called as derived units. And the next one, dimensions. Dimension is nothing but it is the expression of units. For every physical quantity can be derived from fundamental quantity and it is expressed in fundamental quantities. That is, the expressions for this fundamental quantities. For mass, it is M, capital M. In these dimensions, all the letters are in capital letters only. For mass, it is M. For length, it is L. For time, T. For electric current is in I. For temperature, it is K. For luminous intensity, it is candela, that is C. Okay, so we can write the expression in this way: M, L, T, I, K, C. In this form, we can write the any dimension of physical quantity. Okay, if for example here meter per second, in this meter per second we can write this dimension. For meter means it is the unit of length, that is L. So L by, for S means second means unit of time, that is T. L by T. We can write this L by T as L T power minus 1. L T power minus 1. Okay, that means we express the any physical quantity with their powers. Okay, let us discuss some examples, then you will get clear idea on this dimensions. Okay, first of all, if you take the velocity, we know that velocity is displacement by time. We measure, that is for this units are displacement, meters. For time it is the seconds, meter per second, that is meter is nothing but length, second is time. So for this the dimension formula is L T power minus 1. For in case of force, we know that force equal to M into A, mass into acceleration. For mass is letter M. For acceleration, in case of this acceleration is units are meter per second square. For this meter means it is the length L and second square means T square, time square. So L per T square or L T power minus 2. Okay, for M it is the capital letter, mass is denoted in M. For A, acceleration. For this L T power minus 2. In this way we can write the dimensional formula for any physical quantity. For example, area is length into breadth, that is length L into L. that is for m there is no quantity in m, so we put 0 on this m0 L square, and for time there is no time here, so t power 0. So m0 L square t power 0, or only we can write it L square. Okay. And for example, for work or energy, the units of this work or energy are same. Work or energy is equal to force into distance. Force into distance. Here for force, the units, the dimensional formula for force is ml t power minus 2. ml t power minus 2. Distance means that is L. Okay. Here that is the final is m L power 1, L power 1, L power 2 and t power minus 2. This is the dimension formula for work or energy. And coming to the power, we know that power equal to work by time. Work by time. That is the dimension formula for work is m L square t power minus 2 by time, that is t. So m L square t power minus 3 minus 2 and here t power 1. If you come to upper side, that is t power minus 1, minus 2, minus 1, minus 3. This is the dimension formula for power. Okay. And some more examples for electric potential. We know that V equal to W by Q, that is work by charge. We know that the dimension formula for work we already derived previous, that is for work it is m L square t power minus 2, and for charge we know that the charge Q equal to I into T, that is for I, current I, that is symbol I. For T, this time is in T, that is equal to m L square, here t power minus 2, here t power 1, that is t power minus 3 and then I power minus 1. Okay, this is the dimensional formula for electric potential. Okay. And then coming to the resistance, we know that the resistance R equal to V by I, that is voltage by current. For the dimensional formula for this voltage is m L square t power minus 3 and I power minus 1 divided by the current I. Here the total one is m L square t power minus 3, here I power minus 1, here I power 1. If you come this upper side, I power minus 2. Okay. Next one, Boltzmann constant. It is very, very important. Boltzmann constant is equal to energy by temperature. Energy by temperature. For energy or work, we know that dimensional formula m L square t power minus 2, and for temperature, that is Kelvin, K, that is the final one is m L square t power minus 2 K power minus 1. Very, very important one. And next one, coming to the pressure or stress. The units for this pressure or stress are equal. For this we know that pressure P equal to force per unit area. We know that the dimensional formula for force m L t power minus 2, and for area it is meter square, that is length square, that is L square. So here m and L power, here L power 1, here L power 2, that is 1 minus 2, that is minus 1, and t power minus 2. Okay. And coming to the surface tension, we know that the formula for surface tension T equal to force per length. Okay. For force it is m L t power minus 2, for length it is only L. So here L is cancelled, then m L power 0 t power minus 2 or m t power minus 2. It is the dimension formula for surface tension. It is very, very important one. Okay. And next one, universal gas constant, that is nothing but R. R equal to PV by T. Okay. Here P is the pressure, V is the volume, and T is the temperature. We know that pressure, the pressure dimensional formula, that is m L power minus 1 T power minus 2. Okay. and for temperature it is the Kelvin. For V, volume it is L cubed. Okay, meter, for volume it is meter cubed, so it is L cubed. So final one is for this universal gas constant, that is M, here L power 3, L power minus 1, that is L square. So L square and T power minus 2, and here K comes to upper side, that is K power minus 1. This is the dimensional formula for universal gas constant, M L square T power minus 2 and K power minus 1. Next, coming to the gravitational constant, that is nothing but G. We know that force equal to G into M1 M2 by R square. Okay, from this G is equal to F into R square by M1 M2. Okay, and we know that the dimensional formula for force, that is ML T power minus 2 by, for here M1 and M2, there are the masses, so for this M square. Okay, and for R, L square. Okay, that is equal to M power minus 1, here 1 and here 2, so 1 minus 2, that is M power minus 1, and here L power 1 and L power 2, that is L power 3 and T power minus 2. It is the dimension formula for gravitational constant. It is also very important one. Here the very important one is, for this gravitational constant, mass is in negative terms, negative powers. Okay, here some important quantities and their CGS units and SI units. The SI units are very important for exam point of view. For distance or displacement, we know that the distance or displacement, the units are, in CGS there is centimeter and in SI there is meter. Okay, for in case of area, for CGS, here C, that is centimeter square, here for SI units, that is meter square. For volume, that is centimeter cubed in CGS units, and for SI units it is meter cubed. For density, it is kg per meter cube. For velocity, it is meter per second. For angular velocity, radius per second. Okay, and coming to the acceleration, we know that acceleration is nothing but A equal to dv by dt, that is change in velocity by change in time, that is velocity. In this case, the units are meter per second square. In this CGS, centimeter per second square. For angular velocity, radians per second square. For mass, kg. In this linear momentum, kg meter per second. For angular momentum, joule second. For force, we know that the units of force, Newton, and 1 Newton equal to 1 joule per 1 second. And coming to the torque, torque is nothing but force into distance. Force into the units for force, Newton, distance, that is meter. Okay, and coming to the impulse, impulse is nothing but force into time, that is for units of force, that is Newton, for time, that is second. Work, power and energy, the units of this work, power and energy are, sorry, here only work and energy only, there is no power. For work and energy, the units are joules. For in case of power, that is watts. Okay, here there is no power, only it is units of work and energy only joules. Okay, for power it is different, that is watts. Power equal to energy by time. And coming to the pressure, pressure is nothing but force per unit area, that is F by A. For units of F, that is force, that is units of force is Newton. For area, it is meter square, so per meter square, or also Pascal. Okay, and coming to the strain, strain has no units. Okay, I already discussed in strain class. And coming to the stress, units are stress is same as that of pressure. Units of stress is same as that of pressure. So the stress units are Newton per meter square or pascals. Okay. Of this potential difference or voltage or electromotive force EMF. For this unit are volts. Okay. For resistance, the units are ohms. For specific resistance, that is resistivity rho, ohm meter, very important one. Units of specific resistance or resistivity is ohm meter. For conductance, conductance is the reciprocal of resistance, that is 1 by ohm or mho. Okay. And coming to the magnetic flux, units of this magnetic flux are Webers. And coefficient of self induction or self inductance is Henry. For inductance, the units are also Henrys. Okay. And Planck's constant, Joule second. Okay. These are the important quantities and their units. And next coming to the dimensional formulas. Dimensional formulas. For area, we know that area equal to length into breadth, that is here L meter into meter, that is L into L square. So there is no mass quantity, so m power 0 L square. There is no time quantity, so t power 0. For in case of volume, it is L into L cubed. So m power 0 L cubed and t power 0. For in case of velocity, it is displacement by time, that is for displacement it is in length L by time t. So L t power minus 1 or m0 L t power minus 1. In case of acceleration, that is L t power minus 2 or m power 0 L t power minus 2. For angle, that is arc by radius, that is here L by L. So for angle there is no dimensional formula, very important. For angle there is no dimensional formula, that is m power 0 L power 0 t power 0 means it is a no angle has no dimensional formula. Okay. And coming to the density is equal to mass per volume. Mass for mass it is m, volume that is L cubed. So m L power minus 3. Coming to the angular velocity, that is angle by time, that is angle, there is no dimensional formula for angle, there is no dimensional formula. So that is 1 by time, that is t power minus 1 only. Okay. And next one, angular acceleration, angular velocity by time, that is t power minus 1 by time, that is t power minus 2. For force, very important, force F equal to m into a, that is mass into acceleration. For mass it is m, for acceleration L t power minus 2. So the dimensional formula very important for force, m L t power minus 2. Okay. And coming to the work or energy or torque, that is nothing but force into distance. For this force is m L t power minus 2, m L t power minus 2. For distance it is L. So m L power 2 t power minus 2. We already discussed this. For power m L square t power minus 2. For momentum m L t power minus 2. And for frequency is equal to 1 by time, that is t power minus 1. For pressure or stress, that is force per area, and the dimension formula for this force is m L t power minus 2, for area L square, that is m L power minus 1 t power minus 2. And here some dimensional formulas for surface tension, for specific heat, for thermal capacity, for latent heat. Okay. Here the important one is universal gas constant. For this m L square t power minus 2 and k power minus 1 only, there is no md. Okay. And electric current, electric charge, electric potential resistance, specific resistance, Planck's constant, Boltzmann's constant, gravitational constant. Okay, these are the important ones. Okay, I will give the PDF link for this class. Okay, these all the dimensions and units. Okay, and here some important one is dimensionless quantities. Dimensionless quantities, it is very important one. Here we already discussed for angle, there is no dimensional formula for this angle, and ratios. For ratio, upper side and the lower side, that means numerator and denominator both are same units, so that's why there is no dimension formula for this ratio. And numbers and specific gravities for strain and refractive index, they don't have dimensional formula. And some conclusion of this units and dimension here. The third one, the physical quantities have no units and also no dimensional formulas. They are strain has no units and no dimensional formula. Relative density or specific gravity, Poisson's ratio, coefficient of friction, refractive index, Reynolds number, relative permeability, dielectric constant. These have no units and no dimensional formula. And here one more thing is the physical quantities having same dimensional formula. Here momentum and impulse have same dimensional formula. Work, energy and quantity of heat torque, it is the same dimensional formula. Angular velocity, frequency velocity gradient and decay constant, they have same dimensional formula, that is t power minus 1. For surface tension and force constant, same dimensional formula. For angular momentum, Planck's constant and angular impulse, they have same dimensional formulas. For stress, pressure or modulus of elasticity, same dimensional formula. In case of thermal capacity, gas constant and Boltzmann constant, same. Latent heat and gravitational potential, same. Rayburg constant, wave number, same. Force, thrust, tension are the same dimensional formula. The same way acceleration due to gravity and intensity of gravitational field, same formula. And coming to the speed, velocity of light, same. And one more thing here very important is some physical quantities having negative dimensions for mass. For gravitational constant, negative dimension in mass, that is m power minus 1. For specific volume, m power minus 1. For capacity also, capacity, permittivity, conductivity and conductance, in these physical quantities there is a negative mass. Okay friends, thank you.